So what I'll do, I'll show you how to make this, and you guys can do it on your own. I actually won't upload this. I'll show you guys how to make that. So what the definition allows us to do is create what I was talking about is a is a form that's not grounded the way you guys were working on this before, right? So these 3D prints that you made, they somehow were sitting on the ground. These have sort of maybe nothing's up. They maybe sit on the ground or they don't, or we'll see how they sit on the ground. This is really just a test to make, test a sort of 3D printer, also sort of understand a little bit about Bezier curves, and then Bezier surface, right? So we're doing a lot of catenary. I want to see how these print the way the catenaries, right? So when we 3D printed the catenaries, people were like, yeah, like John were like, how how is this stuff standing up? You know, it's you know it's the it's, it's calculus, man. That's why it's standing up. You know? So St. Louis Arch, right? Catenary. I mean, although the St. Louis Arch is not a catenary as far as I know. And there, it just works with the idea of sort of how do you start to produce that type of stepping, and it was a great test, right? You guys did some really thin pieces, and they were actually really successful. So that being said, it's going to be interesting how we might now look at this using sort of Bezier curves. Will they perform the same? So a lot of this is testing it out. And we're not going to just make a one-sided piece. We're going to make a four-sided, or in this case, a six-sided, versus a five-sided, right? Because our fifth side, our sixth side was on the ground. Does that make sense? Cube has six sides, right? So we were just using five of them before. One, two, three, four, five. Now we're gonna look at it. What happens when we make something that might be different? So it produces something like that, right? So we're gonna have to we have to do it. We have to split them in half when we print them, so we then put them back together. We won't be able to print them in midair. Otherwise, we need a lot of support material. All right. So what I've done here, let's go ahead. I'm going to select this whole thing and turn solution off. But I want to do this today. All right. Like in 1 hour. I'm going to do this like in 20 minutes. Show you what this does, and then in 1 hour, you guys are going to be ready. Okay. So put away all your other stuff that you're having problems with. I'm sure it's all time based. Just didn't spend enough time on it. That's my guess. And just watch this. Okay? Alright, good. Alright, so what I'm making here, so this is a box extrude. And basically this is based on 20. What is 20? So let's type in units. I'm showing these as inches. Let's try to make this 1-to-1. So I think everybody should be able to make maybe like 3" by 3". Let's try to push it. All right? Does that make sense? So I'm going to adjust this to 3 inches. It's going to be problematic with my shape, but I'm going to scale these down real quick. You'll see why I'm dealing with this in a minute. Okay, I'll talk about what those shapes are. All right, so I just have a box. So this is just making a 3" by 3" by 3" box. Because then we can probably get all of them on there, maybe pack them tight. We'll see what happens. All right, and what I'm doing then is I'm using what's called, I'm going to turn these on and off as I go through them, a deconstruct B-rep. So it basically takes the B-rep and goes, which is a B-rep is just, it's a collection of surfaces. That's all B-rep means. Deconstruction deconstructs a B-rep into its parts, right? So all its various parts from faces, edges to vertices. Okay? So what we see here are faces, edges, and vertices. So we can go ahead and start to isolate specific faces. All right? Now what we're trying to do is isolate 2 out of the 6. The reason why is we're going to create 2 geometries like here and here and treat them as openings, as fixed openings. They have to be assigned to a face. Does that make sense? So what we're going to do is we're just taking a box and I'm saying pick 2 sides and we're going to put 2 openings on those sides. So just imagine I had a box and I'm saying I'll put an opening and an opening in. Okay? Now these openings, these sides should never be across from each other. Like I don't want to see an opening over here because eventually what we want to do is try to make a surface that connects all these sides. And then we end up with like a real basic tunnel through the cube, right? So we want to make something a little bit more interesting. If you guys are lost, you guys gotta ask, don't hesitate. So eventually you want to make some type of form that's doing something as an inflated shape, okay? And then we're going to figure out where to slice this thing in half, and then print the 2 sides, and then put them together. Okay? This making sense a little bit? All right. So we always want to have sort of perpendicular sides. So everybody understand this? This is selecting from the list item. These are my faces. There's a total of 6, 0, 1, 2, 3, 4, 5. And I'm isolating right now 1 and 5. And I can adjust these. Pick 1 and 4. That I never want, right? I can do that. Okay. Okay, so let's look at what I do next. Then I take this element and I deconstruct it again. So I'm deconstructing this plane back into faces, edges, and vertices because I want to extract the vertices. And I want to extract 3 vertices. 1, 2, and 0. So 1 is here, 2 is here, and 0 is here. And that's going to make a C-plane for me at that position. So now I can reference that surface. Okay. Okay, now what I'm doing is, so I want to prove that, I mean, this is again to sort of see how these softwares work together. We don't do everything primarily in Grasshopper. We're working with geometries here, right? And we're like a visual group of people. So what I've done here is drawn a couple geometries. And these are just really quick P-lines. Okay? And what I want to do now is reference this into Grasshopper. So if I make a curve container, which is that little, it contains a collection of curves. And if I right click on that and I say set one curve, I can pick that and then it'll all of a sudden put that curve into Grasshopper and reference it. Then I can say take that curve And then orient, I'm using an orient command. And orient basically does like, orientate. Orient my my geometry, my curve, from my initial plane, which is world, to my new construction plane. So take this and move it over here. If I preview that, we can see it doing it. Now, we can see it's not in the right spot. Can you see how I'm moving that? So I want to put that there to reference world to world. So this geometry now is being projected onto that plane. Okay? So far so good? And then I can do the same for this. Let me just get that in there. So far so good, guys? You're understanding this? So let me go ahead and turn this all off. Just going to turn this on. So all this is doing is taking this and orientating it into our new C-plane, which is up there, which is part of our face. The cool thing is, if we start moving this around in Rhino, it's going to adjust. If we turn on control points by typing in F